Welcome to solving radical equations and inequalities. Let's get started. So when we're solving equations, we're trying to find x. So 2x plus 1 equals 5. All we would do is subtract the 1 from both sides, get 2x equals 4, divide by 2, and our x would be 2. And if you checked it on the graph, then you can see that the two graphs intersect. Here's 2x plus 1 right here, and then here's 5, the y equals 5, and they intersect right here at x equals 2. So we know we did it right. So now when we throw a radical into the equation and we solve radical equations, we're still solving for x. So we're going to do this example here. And in your example 1, you've got 2 square root of x plus 1 equals 14. And you've got the steps written on the left side. So I'm going to follow those with you. So step 1, it says isolate the radical. What that means is you want to get this radical, in this case that square root, all by itself. So that means we got to get rid of this 2. So you would divide both sides by 2, and this cancels, and you're left with square root of x plus 1 equals 7. Now your next step, according to your notes, is to eliminate the radical, which we do that by applying the inverse operation to both sides. The inverse of taking the square root is squaring it. That's how you get rid of that radical, or you get rid of that square root in this case. So we square both sides, and these cancel, and all you're left with is x plus 1. And then 7 squared is 49. And then your third step is just to solve. So we subtract 1 from both sides, and we have x equals 48. Now before, on the other example on this last slide that I showed you, that the graphs intersected. So if we were to graph 2 square root of x plus 1, it should intersect with the graph of y equals 14. And so we want to check that algebraically by plugging whatever we got for x, in this case 48, back into the x of the original equation to make sure that it's right. So I have 2 square root, instead of the x, I have 48 plus 1 equals 14. And 48 plus 1 under the radical is 49. The square root of 49 is 7, so 2 times 7 equals 14. So 14 equals 14. So that's right. That means my x does equal 48. Now you really do have to go back and check every time, because there will be some times when you plug this back in and it's not right. So you have no solution. So even if you got all the way through and you got a number, plugging it back in, if it didn't equal, you still have to write no solution. So go ahead and try example 2 on your own, following these steps that we just did. We'll also look at it together in class. Okay, after you've tried example 2, let's go ahead and do example 3 together. So the first thing we want to do is isolate the radical. Get that radical by itself, so this part by itself. And the way we do that is getting rid of the 6. So we can subtract the 6 from both sides. And now we just have the cubed root of y minus 4 equals 3. Our second step is to apply the inverse operation. We want to get rid of this radical here. And the inverse of a cubed root is cubing it, or raising it to the third power. So that cancels the cubed and the cubed root, and now we just have y minus 4, and 3 cubed is 27. And then our third step is just to solve. So get the y all by itself. So y equals 31. Now remember, you have to check. So if I go plug this 31 back in, 31 minus 4, that's a cubed root. Then 31 minus 4 is 27. So I have 6 plus the cubed root of 27. And the cubed root of 27, you can also always check that in your calculator, is 3. So 6 plus 3 equals 9. So 9 equals 9, which is true. So that means this is our solution. So remember, if you plug this back in here and it didn't equal, it didn't work, then you have no solution, or your solution is extraneous, which you'll see at the bottom of your notes sheet. That also means that your graphs didn't intersect. So if you put this in your calculator and put this in your calculator, they would never cross. Okay, on the back sheet of your notes, you're solving radical inequalities. Inequalities just mean you've got an inequality sign right here. You can still solve it like an equation. So we subtract the 1, you're still solving to get x by itself. And then x would be greater than or equal to 6 divided by 8, which would simplify to 3/4. So now the only difference with these examples is that we've got, again, a radical. Now a quick reminder, a radicand is just anything that's under the square root. So this right here is a radicand, the x plus 2. So when we talk about the radicand, that's what we're talking about, what's under the radical, or in this case, the square root. Now your first step is to set whatever's under the radical, so set your radicand greater than or equal to 0. So 2x plus 4 is greater than or equal to 0. The reason we want to do this first is because this has to be a positive number. You can't take the square root of a negative number. Remember, that makes it imaginary. So we have to make sure that our x is going to be greater than or equal to 0 because that makes it positive. So we just solve for x, subtract 4 from both sides. 2x is greater than or equal to -4. Divide by 2. X is greater than or equal to -2. So we've got one part of our inequality. Now you want to go back and solve the whole inequality. And we do that the same steps we just did. You isolate the radical, which in this case the radical is all by itself. And then we do the inverse operation. Get rid of this radical, get rid of this square root. And in this case you would just square both sides. So 2x plus 4 is less than or equal to 16. And then just solve. So subtract the 4 from both sides. 2x is less than or equal to 12. Divide by 2. X is less than or equal to 6. So now we have two things here. X has to be less than or equal to 6, but it also has to be greater than or equal to -2. So we can write it like this. -2 is less than or equal to x, which is less than or equal to 6. And if we want to write it in interval notation, which is the way we want to see it most of the time, you'd have -2, 6, and they'd both have brackets, because remember the brackets are if it's equal to. If there wasn't an equal to here, it'd be parentheses. So what you would want to do is check. If we went back, and you can use your calculator to make this faster, but if you pick a number in between -2 and 6, and I plug it in for x, it should end up being less than or equal to 4. If I picked a number that was less than -2 or greater than 6, like -5 or 9, then neither one of those would end up making this statement true. So -2, -1, 0, 1, 2, 3, 4, 5, 6. All of those numbers can plug in for x and they'll be less than or equal to 4. So go ahead and try example 2 on your own, and we'll work on that in class also. Okay, after you've tried example 2, let's go and do example 3 together, just so you can see one more here. So remember, the first step is to take whatever is under the radical, which is called the radicand, so x minus 3, and make it greater than or equal to 0. That way we can see what x has to be. Remember, we want it to be positive. So x is greater than or equal to 3. And you can tell because if this is 3, 3 minus 3 is 0, we can take the square root of 0. 4, that makes it 1. 5, all those make it positive. But if it was less than 3, like a 2, you'd have a -1, and we don't want a negative under a square root. Okay, now let's go back here and solve this. So isolate the radical, which means we need to subtract the 2, and I'm going to move this over here so we can see it better. But we want to subtract the 2, get that radical by itself, and now we want to get rid of the radical completely. And the way we're going to do that is the inverse, which is squaring it. So that becomes x minus 3 is less than or equal to 9. And we just add 3 to both sides. and x is less than or equal to 12. So here are two inequalities we found. So x has to be greater than 3, but we want it to be less than 12. So I'm going to rewrite that. We want x to be greater than 3, but less than or equal to 12. Sorry, greater than or equal to 3 and less than or equal to 12. There's that equal sign underneath. And writing it in interval notation form would be 3 to 12 with brackets around them. So again, that means any number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, you can plug all those in for the x, and this will turn out to be less than or equal to 5. Any number less than 3, 2, 1, 0, any of the negatives, or any number greater than 12, like 13 and up, will not make this true. Okay, I know that was long. Thanks for sticking with me. Try example 4 on your own. We'll check it again together in class. Thanks for watching. See you soon.